Hello, today I want to talk about solving multi-step equations. Specifically in this one, two-step equations. The first example I want to show you, 7x is equal to 4x plus 30. To solve equations, usually we want to bring all the variables to the same side and the numbers to the opposite side. So here's an equal sign. We can kind of put a dotted line there to visually tell us that there's a barrier there. I want to combine this 7x and this 4x together, but they're not on the same side. So I need to get this 4x over to the same side as the 7x. As a hint, when I'm teaching, I usually tell my students to bring the baby to the mama. So whatever your smaller number is, including negative, right? If you think about the number line, whichever your smallest number is, I usually bring that to the same side that the bigger number is on. So using that knowledge, this 4 is smaller than the 7, so I'm going to bring the 4 over. Now in order to get rid of it on this side, I can't just cross it out. I need to mathematically be able to get rid of this whole term, 4x. And to do that, I want to create what's called a zero pair. And that is the opposite of whatever's happening. And this currently is a positive 4x, so the opposite would be if I had a negative 4x. So if I add these two things together, if I have a positive 4 and a negative 4, together they make 0, which is why those two terms cancel out. But anything I do to one side, I also have to do to the other side. I'm going to write it under the 7x because they both have x terms, so they're both like terms. I'm going to rewrite the equation. 7x minus 4x's gives me 3x's left over. I still have the equal sign, so I bring that down. A positive 4x and a negative 4x became 0, so that disappeared. Then I still have this positive 30 left over. Please make sure that this sign goes with this 30. So this is now 3x is equal to 30. Now, the next step, I always ask my students, what math is currently happening to x? And I say it like that because 90-95% of the time, I get the right answer. If I think about what math is going on here, x isn't by itself, there's a 3 with it. And because there's no minus or plus sign and the 3 isn't written below the x with a line, this default shows me that they're being multiplied. So in order to solve for x, I need to undo what's happening. So I usually ask what math is happening and how do I undo that math. So I see multiplication and I undo that by dividing. So I'm going to divide both sides. And you end up dividing everything. If this side had more than one term, then you would divide every term. And to help me not forget that, I usually write my divide line first and then I go ahead and divide by 3. Now, x is what I'm solving for, so I need it to stay. So I'm not going to divide by 3x, I'm going to divide just by that part I want to get rid of, just the 3. So now, 3 divided by 3 would give me 1. X equal to, and 30 divided by 3 gives me 10. And I don't need to write a 1x. Usually I like to say that we're kind of lazy in math. Not that we don't do anything, we just don't like to do more work than we have to. So instead of writing this, you could also just write x equals 10. And that would be your solution. So if you're using this video to try to learn how to do things, this would be a good time to pause and to try to do B on your own. And then check what you did versus what I do after you finish yours. So if you've already finished yours, and or you just want me to continue solving, again, I'm going to bring my baby to my mama, and just like over here, when I have an x with nothing in front of it, I really have a 1 in front of it. So if I need to move this to the other side, what's going to cancel out with a positive 1? I need to subtract 1x from both sides. So I can just write an x there, and remember, I have that invisible line, and because it's on the other side, I needed to do the opposite to move it. So Now, if I write those two things together, if I have 3 x's and I take one of them away, I'm left with 2 x's. This made a 0 pair, so it went away. And then I still have this 13 sitting there. Now, to solve, I ask what math is currently happening to x. It's being multiplied by 2, so I went to divide. I draw my lines first. Then I put the 2 underneath everything. And when I go to write them out, 2 divided by 2 is 1. But remember from before, we don't have to write the 1 in our answer, so I'm just going to write that there's an x there. And then, I don't really know what 13 over 2 is. I do. But you don't always have to reduce your answer. You can leave it as a fraction. Fractions aren't bad. They help us in a lot of ways. And oftentimes your fractions tend to be your most accurate answer anyway. If you wanted to put this as a decimal, though, you could also just say that x is equal to, and I can probably make another video on this, but if you aren't sure off the top of your head what an answer is, if I find my closest number, so 13 is close to 12, half of 12 is 6, so I know I have at least 6 in here. And there's 1 extra, so 1 divided by 2 is the 0.5. You could also use a calculator if they let you, but your answer to this problem solving for x would either be 13 over 2 or 6.5. Either one of those are acceptable answers. So now I want to come to the part where I mention how to eliminate fractions from any solving equation. I know fractions are awful in that people hate dealing with them, but once you know how to deal with them, they don't become that bad. So what you want to do is you want to multiply everything, all the terms you see, everything in the entire equation, by the greatest common denominator, the greatest common multiple. So you want to multiply everything. Greatest common denominator. Also referred to as the greatest common multiple. But specifically we want the denominators because we want to get rid of these things on the bottom here. So if I think about what the greatest common denominator would be, I have a 2, a 5, and a 4. So the 2 breaks out into a 2 because it's already a prime number. 5 is also already a prime number, and the 4 breaks out into a 2 and a 2. So I need some number that contains at least 2 2's, at least 1 5, and I already had some 2's, so I don't need this extra one. So what that implies is if I had two times 2, which gives me 4, and I did 4 times 5, that gives me 20. And the goal of this is I want some number that's just big enough, not too big, but just big enough that I could divide it by every single denominator here. So 20 divided by 2, does that work? It does. 20 divided by 5, does that work? It does. And then 20 divided by 4, does that work? It does. All of these 3 can go into 20. So I can divide 20 by all 3 of those denominators, and that was my goal for the greatest common denominator. It's actually the least common denominator. I'm looking for the smallest number. You could multiply all 3 of them together, but I want what's common, the least common denominator. So what I want to do is I want to multiply everything by 20. So here, I'm going to show I'm multiplying everything by 20. And now, the magic that ends up happening is if I'm multiplying by 20 and dividing by 2, I can actually reduce these. So I can show you that both ways, but just in case the reducing isn't as easy, I'll show you not reducing first. This will give us bigger numbers, but we'll still get the same answer in the end. So route 1 is I actually multiply, and this is like 20 over 1. So 20 times 3 gives me 60, and then 1 times 2 gives me 2. 20 times 1 gives me 20, and then 1 times 5 gives me 5. 20 times 3 again gives me 60, and then 1 times 4 gives me 4. And now I could actually go through and reduce. I'm going to divide by anything they have in common. And what you'll notice is that the number that these both have in common is going to be what your denominator is. So I end up reducing what I multiplied by. So 60 divided by 2 is just 30. And then 2 divided by 2 is 1, so I'm not going to write the over 1. Here, again, I'm going to be dividing by 1, so I don't have to write that. And then 20 divided by 5 gives me 4. And then over here, I have 60 divided by 4, which gives me a 15, and then 4 divided by 4 gives me 1, which I'm not going to write. And now if you notice, this is going to be the exact same relationship, but I have no fractions. So in essence, I've now just eliminated the fractions, and all I had to do was multiply by 20. And I had found the 20 by looking at what the least common denominator would be. Remember, I need the smallest number that could be divided by all of those. Now if you want to skip this step here, because like I said, I know we're lazy in math and we don't like to do more work than we have to, I could come back up here and realize that if I multiply by 20 and then divide by 2, I'm not really multiplying by 20, I'm only multiplying by half that because I divide by 2. So I can go ahead and divide this 20 by 2. So I could do that. I would divide them both by 2, and I would really just get a 10 over 1. And if I look, 10 times 3 would give me 30. I want to do the same thing with these two. I'm just going to reduce them. So 20 divided by 5 I could do would give me a 4. And if I look, 4 times 1 is 4. I do the same thing over here. I want to divide both of these by 4. So 4 divided by 4 is 1, 20 divided by 4 is 5, and 5 times 3 is 15. So if I want to skip this middle step here, all I do is I take that LCD that I multiplied everything by, and I'm reducing it by those denominators. Now I want to solve this just like I did the ones up here. So my very first step, again, what I usually tell all of my students is I say what math is happening to x and how do I undo that math. So here I have that x is being added by 4 and it's being multiplied by 30. So I want to undo those, but I want to do them backwards from how I would if I was evaluating. So if I was evaluating and I plugged a number in for x, the first thing I would do is multiply, because I'd be following PEMDAS. And I've seen this as PEMDAS, I've heard GEMDAS where it says grouping, any grouping symbol, that's fine. But since this is the first thing I would do when I'm evaluating, it's the last thing I'm going to get rid of when I'm solving. After I would have that, then I would add 4. So if you notice, that's on the bottom here. So I say when we're solving, really what you're doing is you're working PEMDAS backwards. So you look for anything that's just adding or subtracting to your x, and that would be my 4. That's what you want to get rid of first. So just like up here, in order to get rid of a positive 4x, we had to subtract 4x. To get rid of a positive 4 here, we just need to subtract 4 from both sides of the equation. And it has no x's, so I put it under its like terms. Positive 4 and negative 4 give me a 0 pair. Then I just bring the 30x down. And then 15 minus 4 gives me 11. And then the math that's happening to x still, we haven't gotten rid of that multiplication, so the opposite of multiplication is division. So then x is equal to 11 over 30. And you could make a decimal, but the fraction is also just fine as an answer. So using the same logic, and on my next example, I'm going to skip this part of mine. I'm just going to do the reduction at the top. If you wanted to try and work them on your own, you can pause the video and try this one, and then see if my steps match your steps. So I'm going to solve D now. Remember, my first one is finding the LCD. And the LCD is what all of these would have in common. I know it has to at least have a 7 in it, because it's a prime number. I know it at least has to have 1 2 in it, but this 4 from over here is really a 2 times a 2. So I need 2's in there so I can cross this 4 out. If I only had 1, then I wouldn't be able to cross the entire 4 out, because 7 times 2 is just 14. 14 is not divisible by 4. So I need both 2's to be able to cancel this part out right there. And then if I have 2 2's, I can at least cancel 1 2 out with that 2 right there. So more is better than having not enough. See, if I just had 1 2, I couldn't cancel the 4 out. But if I have 2 2's, I can cancel at least 1 2 out. So that means that my LCD is 7 times 2 times 2. And 7 times 2 is 14. 14 times 2 is 28. So my LCD is 28. That is the number that I should multiply everything by. So I'm going to multiply by 28. If there's a negative in there, you either need to include it and then don't forget it at the end, or not include it, and again, don't forget it at the end. So I'm going to include it in my answer at the bottom. I'll just keep the minus as a minus. So I'm going to multiply everything by that LCD, which is the greatest common multiple of those. Didn't change this one. It's the least common multiple. Remember, I want the smallest number. Smaller the number, the easier it is for me to deal with. Now, before I go on, I don't want to do this step, so I don't want to have to multiply everything just to divide everything again. So instead, I'm going to go ahead and divide. So 28 divided by 7, if I multiply by 28 and then divide by 7, I can cancel parts of them out. So that would leave me with a 4 here and a 1 here. I'm dividing the 28 and the 7, dividing them both by 7. Over here, 28 divided by 4, and if I think about it, 28 is made up of a 7 times a 2 times a 2, so if I take those away, it leaves me just 7. 4 divided by 4 is 1. And then 28 divided by 2, so half of 28 is 14, and then 2 divided by 2 is 1. Now this is what I multiply. So I have just the tops, so 4 times 3. Multiplying just the tops because it's like 4 over 1, 7 over 1, 14 over 1. So 4 times 3 is 12. There's no x's or anything, so it's just 12. And then 1 times 1 would be 1, and I don't need to write the over 1. Now, I don't want to forget this subtraction, so I'm going to need to go ahead and write that subtraction in. 7 times 1 gives me 7 y's, and then 1 times 1 would be 1, which I don't need to write it. The point was to get rid of the fractions. Here, 14 times 1 is 14. 1 times 1 would be 1, and I'm not going to write the fraction. Now, this turns into just like these above. I ask what math is happening to y, because I'm solving for y on this problem. Y is being multiplied by a negative 7. If it helps you to see that this should be a negative 7, if it helps you to make it a plus and then a negative, so you go ahead and show that this is a negative 7, that'll also show you more that this 12 is a positive 12, right? There's no negative in front. So it's actually adding with y. So I'm working PEMDAS backwards. So the first things I want to get rid of is anything that's just adding or subtracting, which means my 12. So how do I undo a positive 12? I need to subtract 12 from both sides. So then a positive 12 and a negative 12 give me a 0 pair. This was a negative 7, y. So by doing that, I remembered to bring the negative down and group that negative with the y, with the 7, and not the 12. 14 minus 12 is 2. Then I still ask myself what math is happening between the y and the 7. And I see a negative or a minus sign, because it was a minus sign here, but it's in front of the 7, so it implies that it makes the 7 negative. There's still no symbol between the 7 and the y, so that means it's default multiplication. And then the opposite of multiplication is to divide, so I'm going to divide both sides. Remember, I put my lines first, and I put the negative 7 on the bottom. My end answer, negative 7 divided by negative 7 is 1y. I don't have to write the 1. I just write y equals. And then 2 over negative 7, again, it's a decimal. I don't necessarily need the decimal to show that this is the number that I was looking for. So I hope that helps you. I'm going to do another video on solving multi-step equations that are 3-step equations. So there's more things involved with that. So I hope you've enjoyed this one. Look forward to the next one.